Question: a block A having a mass ma 3 kg is released from rest at the position P shown and slightly it moves on the smooth incline. It reaches the bottom of the ramp, it slides horizontally onto the surface of the cart, mass is 2 kg, friction coefficient is 2 by 5. If h is its the initial height, what is the position x with respect to the cart of the box on the cart after it comes to rest related to the cart? The cart moves on the smooth horizontal surface. Okay, so here the block is released from the h height. Okay, so when it just reaches here at this position, so we can calculate the velocity here, right? The velocity of the block A at A position will be like, from work energy theorem we can say that is root 2gh, right? So let's keep it like this only. Okay, now once it starts moving on this cart, right? So now there's a friction, right? So on the block A, ma, right, the mass is ma. When it starts moving on this plank with the velocity this one va, so the friction on ma will be in opposite direction, and the friction on this one will be mu ma into g, and the reaction of this friction will be in forward direction on mc, so that is like mu ma into c into g, right? So now that the C block, the cart is moving because of this friction in forward direction, so it will accelerate, and this A block, ma mass block, will deaccelerate because the acceleration is opposite to the velocity. So ultimately the velocity of these two will become equal after some time, and we have to find the position of x, right? The position x where the relative velocity of these two becomes 0. Okay, means like the velocity of A and the velocity of C comes equal, right? So that's it. So here we'll calculate the relative velocity and the relative acceleration, and relative velocity is 0 of A block after covering h distance. So relative velocity, initial relative velocity of A with respect to C is nothing but VA only. Okay, so from that, with this one, just start on the block on the cart. Acceleration of A with respect to C, that we can see here. So this is the friction force acting on that ma block. So the acceleration of A is like mu into g, and this acceleration of C is like mu ma into g upon mc. So ma and mc are given. Ma is 3 kg and mc is 2 kg. So we'll put the value here. So mu into 3 by 2 into g, right? So that is 3 mu g by 2, right? So the acceleration of A with respect to C. So here that acceleration of C is in forward direction, positive direction, and is in negative direction. So ultimately the acceleration of A with respect to C will be in positive direction, right? This is in negative, this is positive, sorry. So ultimately the acceleration of A with respect to C will be in positive direction, right? In that direction. So so it will be like mu g plus mu 3 by 2g, and that will be acting in this direction, right, on the A block. A velocity is in this direction, so let's take that direction positive, so this direction is negative, right? Okay, and so once we calculate the relative acceleration and velocity, that cart C comes to rest. So only that the block A is moving now. Okay, so and it covers h distance before coming to rest. So the final velocity is 0, and under this acceleration it comes to rest. So basically this x is nothing but the stopping distance, and we know the stopping distance formula, x equal to u square by 2a, where u is that initial velocity which is va, and by 2 acceleration of A with respect to C. Okay, so here relative displacement only we are going to calculate. So we are using the relative velocity and relative acceleration here. So we'll put the values. So VAC is nothing but this one VA, so which is 2g into h is 6 divided by 2 into A of AC, so which is this one, it is 5 by 2. So 5 by 2 mu, which is given 2 by 5 into g. So it is cancelled here, and this is also cancelled, g cancelled. So h is coming at 6 meter. Okay, so that is the relative displacement of the block over the cart. And that's it. That is the answer. That's it. Thank you.